Hey guys, we're going to start reviewing pre-cal today. So the things that we're just going to go over are functions and graphs, just very basic details. So just remember, you need to know the definition of a function. So, and this will help you with all math. Okay. So remember, for a function, you're going to have, for every single input, there is one and only one output. So remember that our input values are x's and our output values are y. So for every single x, there is only one output or only one y variable. So, or y value, not variable, value. So remember that we use the vertical line test to test that out. So remember, like something like this. So if I have a piecewise, so if I were to have an arc and I have a dot here, I have to have an open circle here to make my line or whatever. It can't be defined in two different places. So just make sure we keep that in mind, make sure we understand the definition of a function. That's just going to be very, very, very important. Okay, so the second thing we're going to talk about, I want you to just kind of recall back in your brain, is domain. Domain is all values, all the input values. And so that's also like independent variable, that kind of sort of thing. All of that is our x, okay? That's going to be our domain, and we are going to use interval notation. So remember, if our domain were to stop at 4, it would go from negative infinity up to 4, and it doesn't include 4, that would be there, or negative infinity up to 4, remember, including there. Okay, so just those brackets there, just a quick refresher there. Then we are going to have range. That's all the output values. And again, we will use the interval notation with the brackets for anything there. So maybe it starts at 2, doesn't include 2, and goes all the way up to positive infinity. And then remember function notation. You probably remember this, f of x, okay, is going to be function notation. And then if we are wanting to find, what's the function value when x is equal to 4, then we would say f of 4. And remember, we would go in and replace all the x values with 4 there. And then the last one is a piecewise defined functions. So remember, piecewise defined functions mean that, just like they say, they're a function broken up into different pieces that make one big graph. So normally they look like something like this. So maybe f of x is equal to, and then we have this brace here, x squared for all values of x less than 3, and then 2x plus 1 for all values of x greater than 3. Okay, and so therefore maybe we'll say equal to 3. All right, so that way we are still defined at 3. We don't have a hole anywhere. You can have a hole and still have a function. That's perfectly fine. It doesn't have to fill up every single domain. It doesn't have to be filled up for it to be a function. Remember, just for a function, it has to have only one output. Okay, that's the main thing, to make sure that you understand that. All right, so now let's look at this. So we're going to identify the domain and range for these functions. So with 4 minus x squared, so that is going to be an upside down parabola that is then shifted up 4 units. So it's going to look something like this. It's going to go up here to 4, is going to travel back down. So the domain here, even though what we see, and I kind of had this hard conceptual, I guess, idea of domain of a parabola, is because we never see it get wider and wider and wider, because it's starting to, jump, I guess, rapidly up because we're squaring it. But it does have a domain and range of negative infinity to positive infinity. And then for the range here, this is where the range is restricted. It goes all the way from negative infinity up to 4, and it is inclusive there. Okay. And then we have 1 over x minus 2. So that is our graph. That is 1 over x, and it is shifted to the right 2. So to graph that, it's going to look something like this. Okay, so normally we see the vertical asymptote there at the y-axis, but because it's shifted to the right 2 with that -2 there, then we are going to see that vertical asymptote here at +2. That's a don't let me get away with that. All right, so here we go. This is at x is equal to 2, and then we have that horizontal asymptote at y is equal to 0. So there's probably lots of ways that you could write this, but I would say that the domain is going to go from -infinity up to 0. Don't include 0, gets very, very close to 0, and then 0 to +infinity. Okay, so unioned with, I guess you would say. You would make sure you write that unioned with. And then the range here is going to, oh, it's not, ooh, excuse me. Let's take that back again. Sorry, not 0. That's going to be the range. This is going to be 2. Yeah, that's going to be 2 there. Then our range is going to be the -infinity up to 0, unioned with 0 up to +infinity. That's a U, not a V. Okay? So I just want to make sure we kind of went through that with the set notation. You could also probably say like all real numbers where x doesn't equal 2, and then all real numbers where y doesn't equal 0. That might also work as well. And then we're going to look at just function notation. So we're just going to fill those in. We have f of x equals 3x squared minus 5x plus 6. So what I am, and then I have g of x is equal to 4x minus 13. So what you can see here is I'm going to have 3 times f of -2. So what I'm going to have is I'm going to have 3 times, and I'm going to replace -2 for x. So 3 times -2 squared minus 5 times -2, and then plus 6. So then plugging that straight into your calculator, you don't have to use necessarily the brackets there. That's just kind of if you want to. So that's going to be 80. Make sure I get this right. So that's going to be 84. And then I'm going to do the same thing on this side. I'm going to have -4 times 4 times 5 minus 13. So that's going to be -28. All right, and then we have another example. I'm going to take f of 1 plus g of 6. So I'm going to have 3 times 1 squared minus 5 times 1 plus 6. And then I'm going to add that to 4 times 6 minus 13. And then that's going to be equal to 25. And then I have 4 times g of 2 first minus f of 3. So I'm going to have 4 times 2 minus 13. And then minus f of 3, which is going to be 3 times 3 squared minus 5 times 3 plus 6. Then I'll plug that into my calculator, which equals -56. Now, the really cool thing about this is that on the AP test, if you have to plug stuff in like this, you don't have to simplify it. You can leave it all like that, unsimplified. As a math person, that kind of like irks me. Like I want to, but because you're going to be timed, you're going to want to make sure that you save all your time and energy and brain power. Because if you accidentally were to multiply, 5 times 2, and you get a wrong answer, then that would cause you to get something wrong. So I don't, I want you to kind of be a little bit comfortable with leaving it as, as a I guess, unsimplified form. But so I won't ever count off for that because AP test doesn't count off for that. But I do just want to make sure that you are aware of that. Now, if it's a multiple choice question, these aren't going to be AP questions. This is just for instance and kind of getting you prepared and talking about it. So if it were multiple choice, though, it would probably be in simplified form. All right, so just a quick review, hopefully pretty easy. Just kind of going over that set notation again. Not set notation, interval notation, and then just plugging in values there, and then just kind of looking at that a little bit more, just probably a little bit differently than what you've seen before. All right, so we're going to look at piecewise defined functions real quick. So I have one example here. So we're going to write the formula for this piecewise defined function. So all of these are linear, so that makes it really nice. It looks like this line right here, just based on slope-intercept form, is going to be y equals negative 2x plus 1. And then that bottom horizontal line is going to be just y equals negative 1. And then this line here, we're not given much of it, but that is going to be y equals x, I know for sure. It looks like if I were just to follow that back down, it does go through the origin, so it's just y equals x. So, and here you can see there's some endpoints here and here. So we'll need to make sure we note that. So the formula here, that's going to be, let's just call it f of x. So it's going to be negative 2x plus 1 for x's between 0, negative 5 is less than x, equal to x, is less than equal to 1. And then we're going to have y is equal to, or f of x is equal to negative 1 for values of x between 1 less than x less than 4. Now, I wrote this, so you could write this as equal to 1 in the top or bottom, one or the other. It can't be either. It can't be both of them, because then we'd have something defined in two places. Can't do that. So then I'm going to have y is equal to, f of x is equal to x for values between, let's see, 4 included. So 4 is less than x is less than equal to 6 there. So my function is just defined between negative 5 and 6 there. So again, this is just making sure you're kind of familiar with piecewise defined functions and just kind of being able to identify those and looking at those and being able to just to write that notation.